In this lesson, you will solve linear inequalities by using multiplication and division. So the multiplication property of inequality states that if each side of the inequality is multiplied by a positive number, then the inequality remains true. So for example, 5 is greater than 2. We all know that. So if I multiply each side by a positive number, let's say I multiply by 3, I get the statement 15 is greater than 6. That's still true. Well, if each side of the inequality is multiplied by a negative number, then it is not true. Watch. Yes, 5 is greater than 2, but if I multiply by a negative 3 this time, I would get negative 15 is greater than negative 6. That's ridiculousness. Negative 15 is not greater than negative 6. But if I flip the symbol, negative 15 is less than negative 6. Now that makes it true. So if we multiply by a negative, we have to flip the symbol, and that is a rule that we have to follow. Multiply by a negative, you have to flip the symbol. Of the students surveyed at Holdrege High School, fewer than 84 said they have never purchased an item online. This is about 1/8 of those surveyed. So how many students were surveyed? We want to write a let statement first. So we're going to say let X represent the number of students that were surveyed. So 1/8 of the students surveyed, this would be an expression for that, says that they had not purchased something online, and it was fewer than 84 people. So we can look at our notes and see the fewer word, what that might represent, but we know that this group is less than 84. So now we're going to solve. We're going to multiply by 8 to get this variable x by itself. And x is less than, we do some multiplication here, and we get 672. So we know that 672, less than 672 students were surveyed. So it could have been 671, 670, on and on and on and on. So we would say less than 672 students. You try the real world example in your notes. Now we're going to solve by multiplying. If you look, this is negative 3/7 r is less than 21. So I'm going to multiply both sides by the reciprocal, negative 7/3, negative 7/3. So this will cancel and I'll be left with r. Multiplying by a negative flips the symbol. And when I take 21 times negative 7/3, that's going to be negative 49. Just like yesterday, you have to put your final answer in set notation. Let's try one more example before you try your own. 3/8 t is less than 5. So we're going to multiply by the reciprocal, which is 8/3. You get t. This is not multiplying by a negative, so it stays less than. And then we multiply straight across here, we get 40/3, which you can do the mixed number for if you want to. We put it in set notation, so t is less than 40/3. You try the example in your notes. The division property of inequality states that if each side of an inequality is divided by a positive number, so we know 6 is less than 12, if I divide both sides by 2, I get 3 is less than 6. That's also true. But what about if I divide by a negative? If I divide by a negative, sorry, a little malfunction there. If I divide by a negative, this is going to be 12 is less than 18. I divide by a negative 2, and I get negative 6 is less than negative 9. That is not a true statement. Negative 6 is not less than negative 9. So once again, when you divide by a negative, we have to flip the symbol. So then I have negative 6 is greater than negative 9. So flip the symbol if you divide by a negative. Divide by a positive, you can keep the symbol the same. So 60t is greater than 8. We divide by 60, and we get t is greater than, I believe, let's see, if I work this out here. Don't have my calculator on me here. 2/15. I'm going to go ahead and put it in set notation. T is greater than 2/15. Let's try another division example. Negative 7 times d, so I'm going to divide by negative 7. This side is d. I did divide by a negative, so I flip that symbol. It's going to be greater than or equal to 147 divided by 7. I grab my calculator, and it's negative 21. And I am going to use set notation, so D such that. You try the example in your notes. Good.